All right, ladies and gentlemen, hello and welcome back once again to the only coast to coast radio show all about the information economy. It's called Inside Analysis. Yours truly, Eric Kavanagh, is here. And folks, I'm very excited to geek out on the hardware today, folks. We're going to talk to Patrick Quirk from Opengear, and they help you keep all of your routers running, failover. We have all sorts of troubles that happen. And I'm particularly interested in understanding how this whole agentic universe is going to come bearing down on network infrastructure because we just don't know what that's going to look like. I mean, we've been basing all of our design patterns on human consumption, on human interaction, and now we have these first-class citizens called AI agents that are going to be hitting the network and hitting it somewhat significantly. A human being makes X number of requests per minute or so, and agents can make thousands of times that in terms of their requests. So, what does that mean for your gear? What does that mean for your infrastructure? What does that mean for downtime? I learned a long time ago, Patrick, when I was in the print production business, talking to the guys at the printing press, where they had multi-million-dollar printing presses and they're just
Yep.
cranking out all sorts of stuff 24/7. And he explained to me, hey, man, if that machine isn't working, we're not making money. Right? And you look at the network space, and if your network goes down, all kind of bad things happen. Work stops, people get truncated in what they're doing. It's very frustrating. It's a very serious problem, and that's where Open Gear kind of comes in. So tell us about, first of all, like what Open Gear does generally, and then let's dive
Sure.
into the specifics of this new development.
Yeah, no, I appreciate you having me on today, Eric. So, Opengear, we're focused on network resilience, and network resilience is really a term that has evolved here over the last 5 to 10 years, and especially you mentioned, kind of the agentic age. We'll get into some of that, but really, it started out as simple serial console access. So every managed router and switch that's sold has got a what's known as a console port on it. And that console port is your management interface. So you can come in, manage it, configure it. If it goes down, you can reboot it. You can patch it with, due to CVE upgrades, whatever that is. You can do all that through that console port. And that's really where, kind of our platform started out, were console servers. But then,
Hmm.
people started putting management interfaces in addition to the console port onto those. So then you had to start adding Ethernet in because the two work in concert. And so the whole, essentially a separate control and management plane has evolved in network infrastructure. And that's what Opengear does. We connect your management tools into your network infrastructure so that you always know what's going on. And then we add another layer of failover that gives you always on access via cellular or a secondary network so that when your primary network goes down, you still have that ability to get control and visibility. So one of the things that I like to kind of frame it around is you know uh, visibility without control is just awareness. So if you
Right.
can't actually go in and do something about it when the network is down, then that's when it starts having that impact, like you talked about with the printing press. Right now, your network is down. You're not making money. You're not servicing your customers. So being able to have control during adverse and failing situations is what
Hmm.
Open Gear provides.
That's really interesting. So I've always been a bit of a hardware geek. I kind of get into this stuff. And so you came into the world and said, hey, we want to provide almost like a back door to give management capability to administrators when something goes down. Because right now, if you don't have that,
Correct.
and it actually kind of reminds me of I'll show my age here. I remember when I was a kid, some of the Christmas lights that you got, if one light went
If
out,
one light went
the
out,
whole string
the whole
goes
string
down.
was down. Yep.
Right. And so then what they had to do is do a separate line through. So there's a whole circuit that routes around whatever went out. And, that was an innovation that occurred in my lifetime. Right.
Yep.
You're
Yep.
kind of like that, right? You're kind of like the entity that came along and said, okay, we don't want all your Christmas lights to go out when one goes out. So we're going to help you like get
Yeah. I
management of
mean,
that device.
what's interesting is, these things really did start out as the design engineers wanted an interface that they could get to. Right.
Hmm.
So during the design phase, that's really where these came up, right? It was, putting in that console access, if you will, was something that the designers would do so that, during the development stage and testing and everything else, that they had a way to be able to go in, monitor, reboot things if something went wrong, et cetera. And, it kind of evolved into that independent management plane that you're talking about, which is, you know, um, definitely a key part of being able to have a resilient platform. Um, the To me, one of the most interesting things is, in a lot of ways, a big part of what we're doing is 40-year-old technology, right?
Hmm.
So, but the value of it, that serial port access, is it is at a primitive hardware level. So you
Hmm.
don't have to have a full network stack built up in order to be able to communicate on it. So at the very lowest level, you know, for example, one of the things that we do is we can actually build and provision a network when there is no network. So
Wow.
you can come through our box and go out and provision your entire network, set up, your IP addresses, really do a full infrastructure build up with no network in place through us. And it's because we've got that primitive level of access
Hmm.
that you're saying is almost like a back door. Well, it's more than a back door now, because it is in the, kind of the critical management plane, and it has to be highly secure as well. So, what we're providing is that security and access, that guaranteed access, even when there is no network at the beginning, or maybe you're operational and you have a network failure, we can still provide that access in order for you to be able to restore the intended state of the network.
Yeah, how much penetration do you guys have with the big cloud vendors, with like AWS and Microsoft and Google and those guys? Are you instantiated in those environments as well to help keep their networks up?
Absolutely. Yeah. I mean, we're the interesting thing is you can kind of divide the networking space up, the infrastructure networking space that we're talking about. So not like the telco networks and stuff like that, but
Right.
so not the cellular, but essentially there's kind of that core data center component
Hmm.
where it's been years ago that the inter traffic between the elements inside of a data center exceeded the amount of traffic that was going outside. And
Wow.
now, like with AI, the especially in the training clusters, the vast majority of the network traffic that's going on is between the nodes in the cluster. So that's that those data center networks themselves, if any one of those nodes goes down, you need to either be able to route around it, you need to understand where it is. And so that network management fabric that we provide inside of data centers and AI clusters is key. And then the other two areas that you can kind of break it down into is like distributed computing. So that would be grocery stores, retail outlets, people that have got multiple locations where they need to be able to understand, manage, and ensure that the network is always running.
Hmm.
You think about POS systems, for example. We take for granted, tap to pay. Well, that has to go back through some kind of a network. And if that network goes down, guess what? You don't get to check out at the grocery store, the restaurant. I mean, how many times have you seen places where there's a sign up on the restaurant that our POS is down, sorry, we're closed for an hour, whatever it is.
Right.
If they were utilizing our equipment, guess what? We could have kept them up and running. And then kind of the third area is what I would call campus environments. So campus networks would be, that could be a true, kind of university campus is kind of the thing that comes to mind, but there are also business campuses. So, you mentioned some of the big guys. So like Microsoft's campus would be a great example of that. You go to Redmond, they've got, tens of buildings out, I don't even know how many total buildings they have, but they've got a core campus network infrastructure in there. And so that would be the kind of place that you would think of as a campus infrastructure. And again, you mentioned right at the beginning, kind of routers and switches and firewalls and any kind of access point like that. The vast majority of the managed ones have got a management port on it, and we provide that network that does that management on the backside.
Yeah, so if I understand it correctly, can you step in and replace temporarily, for example, what the network is doing to enable people to continue to get files and do things? I mean, obviously there's some router has gone down, there's some hardware that has failed. And what you're providing in that instance is the ability for operators to come in and go and change things or fix things. But are you actually also then a service layer that is doing what the network was doing?
So we're not typically in the service layer, although we can be. But
I
the
see.
primarily what we enable it to do is for the operator to be able to come in and reroute the traffic.
I
So
see.
let's say one node goes down, but they've got a secondary path that they can go through, but
I
it has to
see.
be, and if they don't have auto failover
Hmm.
or something like that,
That's
you could
cool.
go in and reprovision it to route it around, right?
Right.
But what we provide is that failover functionality for the network management plane. So if their primary fiber connection that is their management network, let's say there's a somebody's got a backhoe out there and they accidentally scoop up and tear the fiber apart. They've suddenly lost access to that management network. We provide immediate cellular failover. So, or we have secondary. Typically our boxes are connected into kind of two wide area network connections, independent fiber from independent vendors going down out independent paths,
Hmm.
and then we have a tertiary one, which is the cellular connection in case you know either or both of those fail. So we do automatic failover to guarantee you've always got access.
Yeah, that's very cool. So, I mean, basically, you are the failover guys. Like you step in to help
Yeah,
make sure networks stay up and running no matter what happens to them. X number of nodes goes down, X number of equipment fails. You go in to give that sort of backdoor access for the management console to allow the operators, the admins, to continue doing their job, reroute traffic however it needs to be done to keep the trains
exactly.
running on time, right?
Yep, and getting that awareness when a node does go down, because sometimes in the primary path you may not know that it went down because that's where your telemetry is coming from. So you can also pull telemetry out the management interface, and we can indicate, hey, we're in failover mode. So that means your main network has gone down, or your main network has gone into failover mode. It's on the B side only, and that may
Hmm.
not be something that you pick up through your standard traffic analysis and everything else.
Hmm.
So it can be used as a diagnostic tool as well, when things start to go wrong before it becomes catastrophic. And I think the other kind of key thing is, so that's kind of that day to day operation.
Hmm.
We talk about our capability as being first day, worst day, every day. So
Hmm.
kind of the first day is when you don't have a network and you can go in and completely provision and build the network when there isn't one there. The worst day is that failure scenario, right? Either
Right.
it's a cyber attack or a human failure on an upgrade that causes the network to go down or something like that. And then the everyday is that kind of telemetry and understanding of what is going on with your network on a given, on a regular basis, right? A real time
Yeah,
basis.
that part of the equation actually interests me as much as anything else. Frankly, the observability and understanding the telemetry. So, we primarily work in the data world, so analytics, business intelligence, data
Sure.
warehousing. But, you take, for example, Hadoop, which came along. It was a bit of a curveball. That was very network intensive because you
Oh yeah.
had to, anytime a node goes down, that's where it got really, really slow because you have to repopulate that node. Basically, it's all going over the network. And so
Hmm.
network traffic becomes a very serious choke point. But the observability stuff is very interesting because you can learn a heck of a lot about what's going on and then re-architect. And I was asking a guy, it's funny, I almost should have collated this show with a different interview I did a couple days ago because it was all about network security and topology and kind of understanding
Hmm.
what's happening and being able to keep the networks serving uses appropriately in different levels of authorization and prioritization
Yep.
and so forth. I mean, there's a lot of stuff that goes into that, like software-defined networking when that came out, which, as I understand it, is sort of dynamic provisioning of components in the architecture, right? So you're sensing a lot of
Exactly.
traffic. And in fact, the example I gave in that conversation was going back to the early days, like in the 1990s, late 1990s, when Yahoo was a huge player in the space. And what were they focused on intently was being able to scale up and then scale back down, like for Black Friday, for example, because all of a sudden,
Yeah.
boom, you got
Exactly.
huge amounts of traffic coming in and you don't want to be losing customers. But at the same time, you want to be able to scale down afterwards because you don't want to be paying for tons of
Yeah.
compute
You don't want to pay for
that you're
that
not
fixed
using,
compute.
right?
Yep.
Because that
Exactly.
was so. Maybe just talk a bit about the observability. What kinds of things can you see that can then help optimize the network itself?
Yeah, so I think kind of the framework that's good to think about this in is, I mentioned network resilience at the beginning, and really there are
Hmm.
kind of three layers to that. So the first is, what is your intent, right? So what is the basic design of the network, and those would go into things like you were just talking about, right? So what percentage of, how much scalability do you need to be able to have from a bandwidth perspective? How are things configured in the network? Are you going to shut nodes down during certain times of day, or change the access rules or rights around it? So that's that kind of network design intent. The second piece of it is, really comes into the awareness side of it, right? So what's the observed state? what is going on with the network right now, and is there a difference between those two things? Because if you
Hmm.
start to see something drift, that's an indication that there's something is behaving differently than your expectation. And
Right.
then being able to go in and figure out, okay, what is behind that shift in how it's operating, right? So intent, and then the observability. And then the third piece of resilience is the control piece that I talked about. So even if if what you detect is actually an outage, you still need to be able to get in with control to be able to remediate it and bring the current state back up to the intended state, right?
Hmm.
So, I think that when you think about it in that kind of a framework, you know, while we're primarily the plumbing that allows you to do that, we also provide the authentication, point-to-point secure links between, a whether it's a NetOps or SecOps or maybe even the IT ops side of things. They can tunnel securely into any device that's downstream of our
Hmm.
network
Oh,
on the control plane. So what that lets you do is, okay, you see some on your observability plane comes up and says, hey, I'm seeing something that's anomalous here relative to the expected behavior. Let's say it looks more like a security play. Well, the SecOps guys are going to come in and take a look. And do they need to shut that node down? So,
hmm.
because one of the things is early action when you've got some kind of an event going on. But if if you go down and shut that node down, what's the downstream effect of that? Right.
Right.
So being able to understand that full ecosystem and what's going to be impacted if you do shut a node down, and can you route that traffic around it,
Right.
et cetera, et cetera. That's really kind of the core of that observability piece.
Yeah, that's good stuff. And you brought up a couple of really interesting points of authentication, for example, because this is going to be another really, really big issue with agents, with AI agents going out and trying to do things and resolve problems or just test systems or whatever the case may be. You want to have
Right.
some robust system for making sure this is our agent. It should have the authority to access this information. It should have the authority to pull this lever or that lever. I mean, these are really, really important things to consider again as we prepare to go down this road. And it is so dangerous. I mean, I have to say we got to go to
Well,
break here in a second, but I remember when OpenClaw came out, one of my buddies who was a developer who was like, "Oh my God, like you have no idea that is like a CIO or a CISO's worst
the
freaking
CISO.
nightmare."
Yep.
Because it's like
Yep.
you're going to just blow up this whole thing. Well, folks, don't touch that. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis with a fascinating conversation with Patrick Quirk of Opengear. We're getting into the gear. I'm a gearhead. I'm not going to lie. I've always been a gearhead, and things are changing. There are so many new interesting devices that you have out there that are really changing. We talk a lot about artificial intelligence and training models. Like one of my clients is a fascinating company called Hammer Space, and they're actually serving the data to the models like Llama 2 and Llama 3 and
Right.
Llama 4. They do massive unstructured data orchestration, and they've managed to cut the hops that data takes from its storage location to the actual GPU from like 10 down to 4, which is a lot when you have 10 billion parameters, right? It's like that's saving
Yeah.
40 billion hops basically. So this is like how I get into the gear stuff. But of course, Open Gear has been on the outside, and it came in as a way to provide this sort of extra layer of resiliency. And then to your point, you're now adding on some capabilities like the observability stuff. And I'd like to get into this authentication storyline because that's very, very interesting. You're going to have various levels or various control points, is what they call it in the risk management
Yep.
world, where an agent can take action or your device can take action or whatever. Tell us a bit about the authentication and what that allows, what that enables.
Yeah, so I think the interesting context for that is what you were hitting on right before we went to break. The amount of data traffic from agents just exceeded the amount from humans, right?
Right.
So
I saw that.
yeah,
Yeah,
which
I
is
saw
just
that.
insane to think about how fast it's gotten to the point that now agents are generating more internet traffic than the rest of, all of humanity combined,
Right.
right? So what that then starts to get into is what is the governance around these agents? And so, you're hitting on one aspect of it, which is, okay, how do you authenticate that an agent is allowed to gain access to a given device? You know, everything around those, kind of that RBAC aspect of it. How do you make sure that they are allowed to do what they're doing? Because the difference between an agent and a human is an agent won't give up. If it was programmed to go
That's a
do
quote.
something,
That's
it's
good.
going to keep going, right? And so, I think that governance framework that we need to really be thinking about is, okay, every agent should be treated, from an access and control perspective as if it were a human.
Hmm.
So what physical equipment is it allowed to get onto? What ports can it actually open up? So if you start thinking about it from okay, I would provision my router this certain way or my firewall this certain way. What are my firewall rules? So when you get into firewall rules, now you're talking about physical ports, you're talking about virtual ports, you're talking about, how many streams can be opened up at any one time, who's allowed to do that. And
Hmm.
so, you kind of work your way up through that stack, and that's the provisioning that we should be putting around agents. Because if you don't build that access framework and that governance around what they're going to be able to do,
Right.
like I said, they're going to keep trying. They're not
Right.
going to give up. And so, making sure that you've got that kind of lattice framework and a really, and I think the other aspect of this is, right now we're kind of in the age of everybody's building an agent, right?
Hmm.
And I think very quickly enterprises are going to realize that if you're doing that, you need to put in, an entire governance control around it.
Right.
Because what you want your agents to be is very narrow, very specific, with very tightly controlled rights and
Hmm.
restrictions. And then
Hmm.
let them, we don't want them to give up in that vein, right? We want them working really hard at what that specific thing is. What you don't want them to do is to jump outside of their lane, right?
Hmm.
So to me, I was, I don't know, saw a video on a Tesla automatic driving that, it started braking and backing off, and the guy was like, I'm going to disable this. I don't know why the car is doing that. And then suddenly, a cop car came around the backside of him to pull over the car in front of them, right? So
Wow.
the autonomous driving figured out the situation before the human did.
Wow.
So, that kind of speaks to how agentic AI works. So if we don't make sure that we're putting in that right governance constraint around it, I think that's where, we could run into some issues.
Now, what role could Opengear play in that world? Like, could you serve because you want a
Yeah,
layered defense, right? You want a layered
absolutely.
defense, and so what are those layers? It seems to me you have a very interesting role to play because of where you sit, because you are tapping into the actual network infrastructure, which is where all
Right.
this activity is happening. Can you explain like what role you would play and how that would work?
Yeah, so what we're seeing our customers starting to ask for is, instead of having, all their agents running at the top level and traversing the entire network all the way through, in order to be able to gain that level of control, that layered defense, if you will, right? So defense in depth,
Hmm.
being able to have like right now, you can take Thousand Eyes or some of the, there's a lot of different tools out there that you can go place at various points inside of your network.
Hmm.
So our equipment now, we're adding in the ability for people to be able to drop, whether it's a containerized application or,
Oh,
eventually
wow.
a small agent down on a node, and then you
Wow.
can restrict what it has visibility to. So, because of the way the management plane network, the way the management plane hierarchy works, you could go in and isolate it down and say, okay, you have domain over, this set of routers, this set of switches, this portion of the network, and be able to restrict that agent down on the device itself. So you can do distributed agents, lock them down, and then if something goes wrong, just like you have today, you can go in and you can shut it down independently. And if be able to maintain that overall control. So essentially getting kind of distributed agents out there, I think, is
Right.
where on that management plane, because they'll be able to gain knowledge a little bit earlier. And instead of having to just push all that telemetry data all the way up to the top, now you can have them at least do some basic things at a minimum, filter the data down and only tell the top layer what is the important things that they're seeing. Hey, suddenly
Interesting.
I'm seeing chirping on this port, or flapping on this port on this particular device. That's indicative of some kind of a injection error, an injection attack or something like that, right? So you could then have it isolated and only send that message up and say remediation is this, should I go ahead? Or you could even put in human in the loop to be the ones that go in and do it. But you can then, effectively you're let the small agents boil the ocean for you and
Hmm.
only give you the key things of where you need to go and remediate before something gets bad.
Yeah, well, that gets back to one of the things that you were talking about before we hit the record button here, which is the pressure on staff, the pressure on human
Exactly.
beings and what they do. I mean, I've always been amazed by systems management software because, in fact, I interviewed a guy, Zohar Gilad, I'll never forget this guy's name, from a company called Precise. They got bought by Idera, I think. And he was
Okay.
joking that in the telco world, it's all black magic, man. Like no one knows what's actually happening. But he's a very, very smart guy. And, but you're just looking at histograms. You're sitting there looking at histograms,
Yeah.
but as a human, you still need to figure out, okay, well, what does that mean? Well, now we have large language models which are remarkably good at taking like giant chunks of random data and saying, okay, this looks like network traffic data, for example, and you can actually learn things from that. Is that something you guys are embracing too, or going to talk about that for a minute?
Yeah, I think the interesting area there for me and what we're kind of the path that we're going down and investigating is when you think about the number of resources and what any individual now, whether they're an IT admin or a network admin, whatever it is, the any one individual now, if you look at that same person 5 years ago, they're now managing 10 to 20 times as much equipment, right?
Right.
And the amount of data that's flowing through there on the networking side is exponentially more than that, right? So if you measure it by the amount of data and endpoints and things like that, it's exploding on a per person basis. In the data center space in general, there's something like 20% of the data center workforce, that actual management of the equipment that's inside of data centers is expected to retire in the next 5 years. So
Hmm.
there's a whole huge cohort of knowledge that's about to walk, 40, 50 years of knowledge that's about to walk out the door.
Right.
So what agentic AI, I think, brings us is that ability to take that expert. So, Eric, you're a firewall expert, let's say, right? And you've been deploying firewalls inside of your corporate environment for 20 years, and you've got all the rules down, and yeah, it's all written down and it's specified and what the process is. But there's an inherent knowledge that you're carrying around that when you walk out the door, even if you train somebody for a year or two behind you, that knowledge walks out the door. Well, with
Right.
agentic AI, we've actually have the ability to be able to take that knowledge and carry it forward. And I think that's going to be the benefit to having a workforce compression or just being able to give better tools to the people that are having to deal with more equipment, more data, more network nodes, et cetera. So I
Yeah.
think that's kind of an area that we've been focusing in on. And interestingly, I'm going to do a throwback for you. About 8 years ago, worked with a company called Litbit. Scott Noteboom was the founder, and he was in charge of data centers at Apple and I think eBay and a couple of other places. And he did this startup about 8 years ago. And the idea was to be able to that if you're an expert, and really where he started focusing on was for data centers. People who are cooling experts, they can walk into a data center and listen and tell you what's wrong with the cooling system.
Wow.
So his idea was, okay, can we go and build a set of sensors and then put AI behind it for you to be able to train that so that it's, acting like, kind of the human sensor that you are
Hmm.
with your knowledge and be able to take it forward.
Right.
And I think that, unfortunately, he was probably about 5 or 6 years early in this idea. Had he
Hmm.
started up now, he'd be killing it, right? But that's I think where things are going from an agentic perspective and how it can enhance the ability of any of the network or security operators going forward. And that's
Yeah.
kind of where we're focusing in on.
Yeah, that's very cool. And I remember learning about IoT. I was actually part of a group that went over to Rome, I guess about almost 10 years ago, for the rollout of their first fully instrumented train for Trenitalia. And so they had sensors on the wheels and on the brakes
Yeah,
and all over the place. And I remember learning that audio is a big source of information because when
it
something
is.
starts squeaking, it's like, uh-oh, you need some grease somewhere, or you mentioned like chirping or whatever, like sounds are very important for understanding what's going on. But you have to have the sensors there. You have to instrument it first, and then you have to train the model and help it understand what to look for. But I mean, all these things are important because at the end of the day, like we said, if that network goes down, you're losing lots of money. You're losing productivity, you're losing
Yep.
morale, all kinds of bad things are happening, right?
Yep, for sure. I think that's exactly correct. And I mean, to me, yeah, I'm an optimist by nature to begin with, but I think this is a really cool time, to be an engineer and to be in this space, because there are so many problems that that have frustrated engineers for the last, 20, 30, 40, 50 years even, that now, kind of in the age of large language models and even just kind of core compute being so much better than it is,
Right.
essentially bandwidth being infinite, storage being free. I mean, we've kind of almost reached that asymptote where we can actually solve a lot of these problems and build in the right policies and frameworks so that you are developing products that are secure from day one, right? That
Yeah.
your defense in depth and your ability to remediate issues on your network now is just a matter of, kind of standard operations, as opposed to it being a kind of a heavy triage react environment. We can now get into a space where we're proactive about these things,
Yeah,
and putting
that's
in place the capability to remediate it before it gets bad, right?
yeah, well, predictive maintenance, right? I mean, that's the other thing. It's not new. We've had this stuff. I mean, in the airline industry,
Sure.
they had predictive maintenance 20 years ago. I remember interviewing a guy
Yep.
when I was working at the Data Warehousing Institute, and he's like, "Yeah, we have predictive maintenance because you learn that when this part breaks, that means that part's going to break. So if this is starting to go, pull it off the off line, fix that part, because otherwise something else is going to break." And there are so many dependencies, and that's the complexity, right? When you have all this
Yeah,
just
exactly.
this long tail of dependencies, the further upstream you can go, the better. And that's where I think it's very interesting that you guys chose to focus on that management console to get that deep connectivity to all the devices. Because that's the other thing too, is that you can now tunnel all the way out to some endpoint to see what's going on there, to get the profile. I mean, when we all worked from home, that was a remarkable change in
Yeah,
topography,
for
right?
sure.
And so the network administrators are like, oh my God, how are we going to get
Yeah.
through this
Well,
day?
yeah, I mean, you think about kind of the cybersecurity profile, right? It's not their basic posture is it's not if, it's when,
Right,
right? And if you think you haven't had a some kind of a cyber attack, well, you probably already have, you just aren't aware of it yet.
right.
And
That's right.
and I think that that's the place that we can really start to kind of change the game, just because we sit on that telemetry and management interface, that you can
Yeah.
actually see what's going on from a control perspective, and you don't have to deal with the the just that wave of data that goes through the data plane, right?
Yeah, right. Well, this is fascinating stuff, folks. Look this gentleman up online, Patrick Quirk. He knows a whole heck of a lot about gear and keeping those systems up and running. We kind of take it all for granted, but trust me, there are people who do not take it for granted, and they are in the
For
engine
sure.
room making sure that all these lights are still on and all things
Shoveling the
are.
coal, right?
That's exactly right. At the coal face, as they say. Well,
Yeah.
folks, send me an email if you want to be on the show. Info@insideanalysis.com. We'll be right back. You are listening to Inside Analysis.